it for like, if it was about taste, like the person, like, let's take COVID. One of the things that's coming out more and more and more, right, are the symptoms of loss of taste, loss of smell. So where is the lesion? So COVID can get in neurons. Neurons, by the way, have ACE. There's an intrinsic angiotensin converting enzyme and ACE system in nerves. All your body cells have these. They have different densities, but it exists in your nerves. Now, when you have an altered taste and or an altered olfactory sensation, is COVID damaging the cranial nerves, like cranial nerve 1? Or is it, altering the glossopharyngeal from the sensors, from the dendrites? Or is the problem more central to where it goes back into the taste sensing region or the olfactory sensing region, somewhere in the middle of that, parietal lobe, the temporal lobe, and the cortex, a little deep when you cut through all three of those. So where's it going awry? Or maybe it's both. And my niece had COVID, and she did well with it. She wasn't sick, but this was back early in her fall semester, and she still can't fully taste and smell, and it's bothering her. The fact that, taste is one of the nice things of our life, to have food and the taste, and smell's part of taste. And so is this going to correct itself? Some people will get their taste and their smell back, but it's really a part of that symptomology. You do get tongue issues, by the way. I was watching a critical care interview the other day, and I can't remember the name. It's this weird, like a discoloration of the tongue that presents in some COVID patients, but it's not one of these hallmark things like a fever or like a cough or like loss of taste and smell, but this swollen, odd-looking pallor of the tongue was something that other people are talking about. And so, of the cranial nerves, they're all incredibly important. We've talked a lot about the glossopharyngeal and the vagus nerve in parasympathetic trafficking and regulating blood vessels and the heart and, all that sort of thing. And so please be aware of these and apply your knowledge as you see fit. And that is a good entrance into the autonomic nervous system. And I have two slides here that outline the autonomic nervous system is its own thing. It's not part of the central, it's not part of the peripheral. It's the third nervous system in and of itself. It's autonomic. It's made up of parasympathetic nerves and sympathetic nerves. So the sympathetics are stemming from the ganglia of the thoracic vertebrae, and then you've got up at the head and down in the sacral region the roots for the parasympathetic nerves. And what this is trying to show, and it's okay, it in combination with the next slide, show you that you've got a multi-step process, that when you've got parasympathetic signaling, what's happening is you've got the central nervous system has a preganglionic neuron, that's this blue one right here. And what it releases when it gets to its target organ is it releases acetylcholine, which interacts with a nicotinic receptor, which is an ionotropic receptor that basically lets sodium in and causes depolarization. Now, you can have parasympathetic activation of postganglionic neurons. So the nicotinic hits another neuron in the parasympathetic chain, and then that can go off and agonize something like a muscarinic receptor. That's a G protein coupled receptor, the domino effect, and I have a picture of that. the post-gang